Hello everyone. This video I'm recording to show how to use a magnetic reed switch and how to write a program in Flowcode. So initially I'll describe the task and then we'll step by step write a program in Flowcode. So in this task, we are going to we'll assume that the magnets or any product which has magnets, it's coming on a conveyor belt and the conveyor belt is running by a motor. We'll use the reed switches to detect the product or the magnets, then write a flow code program to switch on an LED when magnet is detected. And the extension is for those who want to go ahead, count the product, display the counting number on LCD, and the conveyor belt should stop after 100 counts. And the same time, to get a distinction, you have to think of the problems which you may encounter and provide for the solution. So now we go on to the flow code and see how we are going to do that. All right, so let's open the flow code, a new project. And as we were using BL0011, the project board, so I'm going to use the same one. We go on to the component library. And what we need is a sensor. So in sensors, we find the magnetic sensor. And we come down. Now we find magnetic sensor. There's a Hall effect analog sensor, Hall effect digital sensor, and reed switch. We would use reed switch because all we need is detection. Either it should be 1 or 0. Increase its size a bit. And we also need a display. And as the task brief says that we need to display only on a, we just need to display an LED. So, sorry, outputs, LEDs and the outputs. We'll just pick up one LED. That's it. This is LED 5 millimeter. size. Let's see properties. The properties of LEDs. So LED is connected on A0 port. Its color is green. We have turned it to red. Red. Okay, and then we see the properties of read switch. Now it is active high. Active high means then when the read switch is going to detect, the output will be 1, and that will be the active high. All right. None of them needs initialization, so we just start up with a simple program. We put a while loop, and then we put in a component macro, and the component macro is the reads of the read switch. We say read the state, and then it should return value. Where it's going to return, we need to define a variable. And the variable is say magnet detect. Its value is either 0 or 1, so we can use a Boolean type variable also and a byte type variable also. Both will do. Let's leave everything the same. We just define the variable magnet detect. Okay. Okay. Then what we want to do is that we want the LED to light up. But it should be based on certain decision. So we put in a decision, and in the decision we say if magnet detect is equal to 1. Okay. Once it is equal to 1, then what it should do, we need an output. Need an output on port A as 1. This is one way of doing it, but otherwise we can also use the LED. We can just say turn it on, or let's keep it simple. We say turn it on. We don't put the port. It should stay on for how long? Let's say it stays on for 1 second or 500 milliseconds. That's enough. And after 500 milliseconds, it should turn off. Again, very off. 250 milliseconds. You can choose the delay as is comfortable with you. What it's going to do is that it's going to detect, once it's detecting one, then it's going to switch on the LED for 500 milliseconds, then switch it off, and then go back to the while loop, and it will continue doing that. So let's debug the program and let's see how it works. If there is any fault, we can. One or more pins of the component read switch are not connected to the microcontroller. Simulation or compilation may not behave as expected. Okay. So what fault did we do? Let's see that. Yes, the connection, the pin is not connected. The read switch was actually not connected. So where are we going to connect the read switch? We connect it on port B, pin 0. Yeah, that's fine. Okay. Okay, let's try it. Now we slow it down and check why the LED is not coming on. Now the LED is not coming on because magnet is not being detected by the read switch. In simulation, this is going to be the results. But to check in simulation whether our program is working, what we will do is that we'll stop the program, and in the properties of the read switch, we would say active low. So this means that our program is actually detecting ones, therefore normally it will be 1, and in case it detects the read switch gives out a low, a 0. So in simulation we'll see that it is working. So you see the light comes on and goes off, comes on and goes off, and you can see the program is running and going on the right side. But remember, this is simulation only, just for checking. So in actual program, we would need the magnet read switch to detect and then come on this side of the program. So in properties, we put it back as active high, and that's how it's going to function. And we save this program. As read switch drop. So I would like you to practice this and then go on to the extension and put in a counter where it's going to count the magnets which are going through the machine, and then at the same time, if you can use the relay to stop the conveyor belt. So these two things you can do it yourself, and we have done it in the can counter project. Thank you very much. That's all for today.